Hello everyone, welcome to ECS CDM 12 Media Computation. Today we're going to be talking about objects and arrays. We are going to go into more complex data representations. And many of you may have been feeling this. Sometimes you're like, hey Josh, I want to do this particular thing in code. Multiple raindrops. Multiple versions of a similar thing like a car that I want to replicate many times. But I don't want to keep a variable around for each one of those because I want like 100 of them. What do I do? Or I want something that combines together a few different data points. Like let's say a length, a height, a radius, and locations all together in one compact representation without a bunch of variables hanging around. How do I do that? Well, we will reveal both of answers to both of those types of quandaries today. Oops. My OBS output window is not going to advance my slide deck. There we are. Arrays. Okay, let's motivate arrays. What if you have a collection of objects? Like stones of different weights. How could you work with this data efficiently? So, what many of you have done so far is if you have a bunch of different objects, you'll have like stone weight 1, stone weight 2, stone weight 3, x location 1, x location 2, x location 3, y location 1, y location 2, y location 3, and that doesn't scale well. It's easy to break these. They're not easy to work with. If you want to, let's say, take all of your stones and there's a big storm that comes through and you want to roll all of them by 3 pixels to the right. Well, with this, you would have to go through each one of these. You'd have to do stone x1 plus 3, or plus equals 3. Stone x location 2 plus equals 3. Stone x location 3 plus equals 3. Stone x location 4 plus equals 4. Each individual stone, you would have to directly write a line of code to change the variable that controls its location. Right? Well, you kind of probably getting the hint so far, like through iteration, through conditionals, that we like powerful representations that can do a lot for us with a few lines of code. Arrays are one of those. This is cumbersome. It's hard to access particular entries. Let's say if you want to see, particularly if each one of those, okay, here's a good example. You want to move all of them, but you also want to know when one of them falls off a cliff to do a falling animation and the book into the water. You would have to write if statement, checking the location of each one of your stones directly. There's no way to put that in iteration. And conditionals can't check over a range of variables for you natively. So this is tough. Arrays help us with this. Arrays are indexed lists of items. So you can have a bunch of items. You can have your array called stones, and it will hold all of our stone weights, and it will hold all of your stone weights. Now, all items must be the same type, so they all must be ints, floats, colors, etc. Even classes, which we'll talk about later. And they should be identified by a name and an index. And because this is computer science, and because we know our integer representation, our binary representation of integers starts at 0, our indexes start at 0. So the first item in an array will have an index of 0. This is how you define a simple array of stone weights. Int, and then some square brackets with nothing in between them. Now that tells Java that stone weight isn't a single stone weight. It's actually an array. It actually holds many values, many integers. An array of integers, all laid out. And then we have this curly bracket notation with the commas. This is creating an array on the fly for us. This is creating an array of integers that have 3 values in it. Index 1 has value 3, index or index 0 has value 3, index 1 has value 54, and index 2 has value 7. So now our stone weight is not a single variable, it's a container, an array of 3 variables. And there's a special notation here to get to, so you can get to each one of the boxes individually, each one of the variables individually inside the array. And here's what it looks like. So stone weight 0 is how you get the first box out, the 0th box. And if you want to get the index 1 box out, you put 1 inside the square brackets, right? So you can use these just like you'd use variables elsewhere. You can use this in arithmetic. You can use it with the basic math functions, arithmetic. You can use it in function calls. You can use it to pass parameters around. So here's an example. Let's say for some reason we want to make the third stone weight be the second stone weight plus 6. So index 2 stone weight should be 6 more than index 1 stone weight. This is how we'd do that. So let's take a look at this. So here we have our left-hand side in our assignment operator. And here's our math, 6 plus stone weight index 1. Now stone weight index 1 will go and look inside of our stone weight array and pull out 0, 1, pull out the 54. 6 plus 54 is 60. So that's what this arithmetic pulls down to 60. And then we will assign the index 2 stone weight to be 60. So here, instead of 7, we'd have 3, 54, 60. All right, I want to pause for a moment. Questions on this? Are we going, yes?
Actually, no, I'll wait for the example.
Okay, that's fine. All right, so the idea here is, do you want to understand this basic notation of the square brackets? You can think of this as almost like a card catalog in a lot of ways. So the 3, 54, 7 is actually an optional initialization where you can give it a set of values originally. So you'd have an array with a length of 3 with these particular values. The general form for declaring arrays looks like this. So you have the type, so float, color, string, doubles. And then you have the square brackets with nothing in it. That's to say, hey, this is an array. Not just one, but an array of many. Then you give it a variable name, just like before. What are the rules for making a variable name? Does anyone remember? No one wants to shoot for the gold star today? What can't you start a variable with? A number, right? Okay, just quick check, getting that loaded in your brain. And then we have our assignment operator. And so here is how you make a new array without a set of values in it already. You're just, right now, if you just left it at this left-hand side, you would have basically something that would reference an array, but there would actually be no array created yet. There's no actual values associated with that array, right? So this is like a label. So if you have a box, an array box, you need to actually have an array to put in the box. If you declare it without this right-hand side, you basically have an empty box where array can be. And so it's important that we actually put an array in there. This is what this right-hand side does. This is a shorthand notation for creating an array with these values that gets stuffed directly into that stone weight array box. Now here, we're using the new keyword. And so we'll be using this keyword going forward. This actually applies to objects. So this is actually making a new version of an array, just a new array for you to use. And its values will be whatever the data type initialization values are, so integers. All the values would, by default, be 0. So if you made a new int size 5, you would have an array created for you of 5 zeros, and that array would be associated with whatever name you chose. And then you can use your name with the square bracket indexes 0, 1, 2, 3, 4 to plot those individual values. Here's an example. We're going to keep this abstract. We want to make a list of integers. So here, what we have is a new int 42. This would give us an array of 42 zeros, because the default value when you create a new integer and you don't assign anything, its value will be 0. So you have 42 zeros that you can access. So you can access with indexes 0, 1, 2, 3, 4. I won't count all the way. 41 will be the last one. Questions? I mean, this is a little different type of syntax than what we've seen before. So it's appropriate to ask questions and clarify. But we'll be going over several examples today to help with that. All right. Arrays have a fixed size. And this is for efficiency, because what it's doing is it's taking a big stripe of your zeros and ones that are in your memory and getting the size of 32 integer sizes. So integers in Java are 32 bits. So it's getting 42 times 32 bits in one big area, saying, hey, this is now integers. Big box, 42 integers. And then int list is getting a label, a reference to where those 42 integers exist. So a fixed size. It's hard to change that dynamically. Now, there are data structures that do change dynamically, and we may cover some of those later in class, but I don't want to confiscate that, or to obfuscate that now, or to make this a little more convoluted than it needs to be. It's already bad enough. So let's take a look at the caller arrays example. Silly me, I closed my folder with my examples in it. One moment. Materials, examples, arrays and objects, color arrays. Oh, and I accidentally copied a bunch of stuff I shouldn't have. Let's get rid of those. No, no. Okay, one moment. User error here. Let me make sure. Yeah, okay, I copied over the wrong folder. I'm going to delete those right now. So if you've downloaded them already, you'll have to re-download them in just a moment. Color arrays PDE. Okay, this will be better. So if you already downloaded examples, please download them again. I just refreshed them. I copied over a backup folder instead of the folder I really cared about. Let's get rid of the image. Okay, so here we have this color arrays example. And the first thing we do is make a new array. Hello, Armfree. Come on in, have a seat.
I lost count.
I'm sorry, I messed you up.
No, you're good.
So our color array. So color is one of those primitive pass-by value types in processing that we have access to. So color, square brackets, to denote that this is an array, not just a single variable, but an array. We're calling it ball color. And part of my Midwest accent here, color will probably sound funny for me for a little bit. Please interpret it in good faith. We're making a new array of colors that have 3 values in it. The index 0, index 1, index 2. Right, so we're getting those values back. I'm pretty sure the default value of color is black, so 0, 0, 0. So now we have this label ball color, which then points to this box that has 3 colors, that has 3 boxes in it, in our warehouse. Yes.
What state are you from?
Indiana.
I told you! Oh my god. Man, I told you it wasn't Illinois.
I have nothing against Illinois, but Indiana's better.
You didn't say
And that was, I did post my college that I went to today. And off topic. But yeah. So you get a little bit of Southern mixed with a little bit of Midwest accent. There you go. What are people from Indiana called?
Indianans. No.
Nope. This one's weird.
Indianapolis.
Indianapoleans. Wow, that's very imperialistic. Wow. Hoosiers.
Why do I feel like I think that?
There's a movie, Gene Hackman movie. It's very popular basketball movie called Hoosiers. Small town basketball team wins the state championship. Anyway, classic movie there. So that was a total aside. Apologies for those listening to this later. I'm from Indiana. I'm a Hoosier. There we go. I'm mostly California now, though.
Mostly.
All right. And so we have a count. We have a diameter. So our basic type of things here. We're going to be drawing some circles. We're crossing up a window, 600 by 600. Today I'm actually using the Pico 8 color scheme. Do I have this open? Okay, I'll show you this just real quick so you know the color schemes we're using for today's examples. Browser, Chrome. Here we go. Get out of here. So this is the color scheme that we're using today. These basic colors for Pico 8, the 16 colors that Pico 8 gives you access to. All right, so we're setting our background, setting our frame rate, and we're setting our array to hold 3 different values. Each one of the indexes in our color array, which is size 3, we're giving each one of those indexes a color value. 1, 2, 3. So we're assigning this color to index 0, this color to index 1, this color to index 2. Now, we're going to draw. And so we're keeping our frame count, %10, so mod 10. What does this do? What does mod do again? Yeah.
It gives you the remainder.
Exactly. So every 10 frames, it'll start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we'll go back to 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So every 10 frames, we're increasing our count. So since this example works at 30 frames per second, the frame rate is set to 30. We're going to have one count every third of a second. So 3 counts a second. All right. And we're going to set first our fill to ball color 0, and then draw an ellipse at 120, 100 with our diameter, which was set to 120. We'll use ball color 1 and draw another, and ball color 2 to draw a third. So we're using each one of our 3 colors. Now what we're going to do is we have a little bit of code to change the color over time. So we're taking our count and we're modding it by 3 again. So this will always give us a value of 0, 1, or 2. So the remainder dividing something by 3. So here we're taking our count, mod 3, and setting the fill that we're drawing the first ball with. Then we're doing the same thing, but offset by 1 for the second ball color, and the same thing offset by 2 for the third ball color. What do you think is going to happen here? Prognosticate for me. When I press play, what's going to happen?
One and like
How many balls would there be? One, two, three at 100. 1, 2, 3 at 300 height. There'll be 6 balls. What about the first ones? Will they change? No. The bottom 3, will they change?
yeah.
How will they change? How often will they change? We'll start easier. We're increasing our count every third of it, every 3 times a second. So our count is changing 3 times a second. So that's how often the balls will change. How will they change?
Color.
Exactly. They'll keep counting up through the color index. First, they'll start. This one will first be getting the 0th color from the 0th index color from the color array. First, second. So index 0, 1, 2. Then it'll increase by 1. So this will be 1. This will be 2, and this will be 0. Right? So we're going to stripe. We're going to just pass through these colors. Yes.
How does it reset to 0?
So count keeps increasing 1 time, 3 times a second, and the mod operator will divide it by 3. So the remainder will either be 0, 1, or 2, which is exactly what our indexes are. The number of indexes we have, 0, 1, 2. Any more questions on this? All right. I need to pick up the pace. But we got through our first example of arrays, our first complex type. Congratulations! You all now know what a complex data structure looks like. You've done your first one explicitly. We looked at it. All right, so array length. So if you get an array, it could be a lot of sizes. You could change its size over time if you want to. You may not know what size it is coming in. Like let's say if you have a balloon color changer class, a blue color changer array, and you want to stripe through a bunch of colors, you can do that. When you have an array, it has a special property. If you do array.length, so ball colors.length, it will return how many items that array can hold. So that 42 value here, that's the length. So if you called int list.length, it would return the integer 42, the size that it can hold. So if you do this, if you make a new array A, and you give it new int 10, if you print it out a.length, it would print 10. Notice that this isn't actually a function. This is a property. So this is just a variable that you can access with this dot notation, which we'll talk about a little more in just a moment. That holds the length of the array. So no need for the parentheses. So when you call this, it's important to know how length compares to the indices, to the indexes in your array. So the important part here is that if a.length is 10, so our example here, our example here, a.length is 10, so that's the size of the array, but the last element in it is 9, so we have 10 of them, right? But we start counting at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we did a bracket 10, that would be the 11th item, and you'd get an error. Out of bounds. Index at line whatever, out of bounds for array A. So the last element in an array is actually length minus 1. So that'll be handy for you when you make for loops. Manipulating arrays. There's a lot of things you can do with arrays. There's a preset set of functions that you can use. And I'm happy to go over these a little more in detail if we have time at the end of class, in office hours, maybe even next class for review. Shorten, which makes the array smaller. Typically, by default, chops 1 off the end. Just takes the last value, gets rid of it. Concatenation. Just like we do our plus signs and print line, so we make our strings into bigger strings to print out. Well, concatenation will take 2 arrays and make a bigger array by smushing them together. Subset. That'll allow you to take a small amount of values for your array, say index 2 through 5, if you want to get a small section of it. Append will add another value to the end of the array. Splice. You can take 2 chunks of an array and splice them together. Make a new array. Expand. You can take your array and simply just add more space to it. Now, these are kind of expensive, right? Because these are actually creating whole new arrays for you. We'll take a look at that in just a moment. But there are ways to actually modify the values in the array. You can call sort, which will sort the values of the array. This works well for integers. It works well for floats. It does what you expect. Lower values will be first. Higher values will be at the bottom of the array. And sort's expensive. This is a computer science topic. I encourage you to look up the Hungarian university that does the sorting algorithm. So how the computer actually sorts. They do that through dance. Maybe I'll put a link to that in the class notes or in Discord. So you can sort, you can reverse. So the last index, the length minus 1, will be index 0. Index 0 will be length minus 1. And it'll swap, reverse the order of everything in your array. So these take array as arguments, and we'll take a look at that. So you actually call sort and put your array as the first parameter. Same with reverse. All right, so the array functions, the first ones we talked about, they don't actually modify the original array. They keep your first array intact and make a whole new array for you. Example, we have a string of states. I probably should put Indiana in here, shouldn't I? We're doing this. We're doing this. You have changed class today. Where are we? There we are. Get out of here, Ohio. Get out of here, Buckeyes.
Hey, my dad's from Ohio.
My town I grew up in is right on the border between Indiana and Ohio. My mom actually worked in Ohio. But that's not totally germane to class. All right, so now we have Indiana, but I didn't actually change it in the notes. Oh geez. This is an intense operation here now. Oh boy. There we go. Okay. So these functions, they don't modify the original array, they return a new one. So here's an example. So if we have an array of strings called SA1, and we give it a default we give it a default array with this short notation with 3 strings in it. Index 0 is the string to see the characters I in space. Second index, or index 1, is NY space, and index 2 is CA space. And we call the shorten function on the first array, on SA1. This is what happens. So, and we stash that into SA2. When we print SA1, it still contains all 3 values. If we print SA2, it contains only the first 2 indices. Right, so shorten takes whatever array you have, creates a new array that's just 1 length less, and gets rid of the last value. The first array still exists. There's still a box for the first array. The second SA2 is a new box with just a new array of boxes with just one less box in it. So you can update the array by assigning results to it. Right? So basically, we can call shorten on SA1. It'll generate that new one less shorter box, return it, and then basically we'd be throwing away the larger box and replacing it with a in the warehouse would be pointing to the new shorter array of boxes, array of variables. Yeah.
But you can't change the length of the array, right?
Right, and we're making a new array and just ignoring the first one.
So
We're just leaving those boxes on the shelf. They're not referenced to it. We don't have a label to them anymore.
So that's a new array, but with the same name, like SA1.
Yeah, so let's review. The name SA1, that's just a label, right? It says, okay, my array is at this location in the warehouse, right? And so while SA array has the first example here, the Indiana, New York, California array, that's a box over here. Now we call shorten, which makes the new array of boxes, just two boxes this time, with Indiana and New York in it. So now we have SA1 pointing to the first array, and now we're changing where SA1 points to the second one. Now nothing is pointing to that first one anymore with California in it. Right now we are just, SA is now just pointing to the new one that was made. Does that make sense? Right. And so if you don't have a reference to that first anymore, that's what we call a memory leak. Or you have data that's just hanging around with no way to use it. That won't be on the test. That was an aside. All right, let's look at rect array. All right. So now we have an array, 8 long, called square length, 8 integers. Scale of 3. Okay. We have a big window size this time, so I may need to move some things around. 1500 by 600. We're setting the background, frame rate to 20, getting rid of the fill, rectangle to center. You've seen all this before. And so what we're doing here.
Josh, I'm not sure if I'm
It's still the blue.
Oh, it is. I'm sorry. My bad. Thank you for letting me know. All right, let's go back. All right, so now we have our square length with 8 arrays, or with 8 integers. Our square length is an array with 8 integers in it, all default values of 0. I have a scale of 3. Integer hanging around. We'll see what we do with it. Window size is 1500 by 600. Background, frame rate, no fill, rectangle center. All standard stuff. Now we're assigning some values to the different sizes of the squares. So square length 0 is 40 times scale, 30 times 1 is 30 times scale. And going on here, we're making a bunch of different arrays with different sizes, different scales to them, different scale values to the length of the arrays. Now we're setting a stroke value. When frame rate equals 20, we're setting the background, and then we're sorting the arrays, the square length arrays by square length, right? So now they're all over the place, right? Highest value is at the beginning, lowest value is at the end, and they're all mixed up. So we're going to sort them. So the lowest value will be first, and the highest value will be last. All right, we're doing that at frame 20. So just 1 second in, we'll shorten them all. Now, when the frame rate is greater than 30 and less than 55, so we have, roughly seconds 1.5 to just about second 2, or 1.5 just about second 3. We will then do some modifications. We're going to reduce the last square length by 2, and we're going to reduce the indexed 5 square length by 1. Then frame count 65, so second 3.25 seconds in, we're going to reset the background color, so we're going to wipe the screen, and we're going to sort them. So we're going to this would change the values in the arrays, so they could be messed up. So we're making them sorted again. Then at second 4, we're going to add a new box, a new square. Then second 9.25 to much later. Every frame, we're going to change the length of the array. We're going to change the last array and make it bigger and bigger and bigger. And then this is, we haven't drawn anything yet, right? We've just been changing values in the array. Here's where we draw them all. So this is important. This shows off the value of iteration plus the value of arrays together, which is really handy. So int I equals 0, I is less than square length dot length. And notice the dot length is red. This is a key, this is a particular, particularly well-used, well-known method that is special. That's very common in almost every Java program that would use arrays. So it's highlighted just like a keyword is. And then we're increasing I. So I would go from 0 all the way to 7. So it would go, so the length is 8, right? So we would go through this 8 times. And as soon as I is 7, would still be less than the square length of 8. So that'd be our 8th rectangle, would draw it. Then I would become 8. And 8 is not less than 8, so we'd break out of the loop, and we're done drawing. And we do this each frame. Let's take a look. Okay, let me move this over. There. Maybe we could still see some of it at the same time. Let me restart. So now you'll see that several things happen, right? We're changing the values, we're resorting. This one's getting bigger and bigger and bigger and bigger until we end with our last scale factor. So one more time. So they start unsorted, and then we sort. One more time. You'll see that they're all jumbled up, and then they immediately get sorted. They get their values changed, and then they get resorted again. And then we add one to the end and grow it. Great. So this is one you should study. This shows off a lot of basic capabilities of using arrays. So this is one you should look through and become comfortable with all the lines of code. You can have arrays inside of arrays. Here you can make a table, just like a spreadsheet. X and Y locations, X and Y cell values. Right? So we basically have an array with each index in it being an array itself. So here, if you want to get an individual value here, whoops, you use 2 square bracket index notifiers. So the first one tells you which one of these arrays you should be looking at, and the second value is where inside of that array you should look. So 1, index 0, index 1. Okay, so we're looking at this one right here. 2, okay, 0, 1, 2. The value is 7. Right, so I'm sure all of you have used Excel and have done like the letter for columns and number for rows notation. This is very similar. And you wonder why we do all those boxes with all those for loops in the lab for the last 2 weeks? It's really to set you up for understanding this. Now you can start thinking in rows and columns in your code. Well, here's a very handy notation for making a bunch of those. Now let's say you have your boxes on the screen, right? And you want them to ripple as you pull the mouse through the screen. Well, now if you have a value for each one of those boxes, you can change their sizes independently. Now you can do all sorts of cool effects. Have any of you ever played a two-dimensional game? JRPG, maybe something that has tiles in it? Well, this is how you make a tile map in your game. Or you take a map of tile and you find you find your tile in your sprite map that's a part of a road, and then you can start like putting the index in your tile map into all the places in the array that correspond to where you want to draw on the screen for that road to be. You want a tree? Find the tree for the sprite. Find its index in your sprite map and put it in your 2D array of what you're showing on the screen in that particular location. These are handy. Want to do some matrix math? You can use it to do that as well. Arrays and arrays. And these can go as deep as you want. 3D, 4D. Actually, I don't know the limit of what Java can handle. I have to look that up. At some point, though, you'll want to use a software package that handles arrays in a more friendly way than this notation. But for 2-dimensional and 3-dimensional arrays, it works pretty well. Okay, so that was our break on objects. Any questions on our break on arrays? It's the last thing we'll cover. Any questions about this? All right. We may have to continue this next class. This is a lot to cover in one class, so we'll certainly leave time for review next class, but we may take a few minutes of it to finish this lecture. All right, now let's talk about objects. Objects they're little bundles of data and methods. So they're variables and functions all nicely packaged together. So just like we have arrays where you can call sort on them. So we had our array.sort. We had array, dot. So going back to our examples. Wait, actually, okay, we'll just, I'll go forward. I don't want to go back too much. These are all packaged together to make a nice little effect. So data and methods. So we'll look at a star example again. So we'll revisit our star example. So a star is both data and operations, right? So with a star, what do you need to know about it? With our star example, what were the variables involved in drawing the star? Does anyone remember? Yeah, it was actually, we didn't actually vary the color in the stars, but that would be a great one to have as well. Yeah, so we had stroke weight, we had the lengths of the majors and the diagonals, which were different. We also had its position, right? That's a big one, position. So that's the data involved. Now, what's code involved with the star? Like what code would there be? What function would we want to use with the star? Remember when we made our own function last time? What did we do in that star function? No one in the back? We drew it. We drew the lines. We made it happen on the screen. We had a bunch of line calls. We did a little math. We put that in a function so we could call that function many, 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 many times in a for loop and draw a bunch of stars. So that's the code. Drawing the star is operations. That's a function that we want bundled together. So now what if we just had this thing we could call it a star, and we could use that fancy dot notation, change its x and y positions, and say draw. Star.draw. Star1, S1.draw. And just draw it on the screen. That's what we're trying to get to here. That's what objects get for us. And this is a way of thinking and organizing your code and your solutions to problems. This is called object-oriented programming. Have any of you heard of this before? This is a popular programming paradigm. All right, we got some bobs. All right. So objects, they're data types. Just like caller, just like int. We're making our own data types here. And the power of programming is we can define what that data type is and how it works and what it does. And then we can use the new keyword with it and make new versions of it and assign those to variables and use them everywhere. So a class, this is a definition of your new data type that you're making. An object is taking that definition and making an actual box from it that you can then modify and use. So there's a difference between like the blueprint or the specifications of a box, that is the class, and then actually creating a box and filling it in with the proper data values, that's the object. So a class definition and then an instance of that class. Have a great day. Let's take an example of car. This is car. We know some things about the car. We know its mileage, color, weight, model, how many turbo boosts it's used. We can do things with the car. Accelerate, brake, steer, change the radio, put it in autonomous driving mode. If we create a class for a car, we'd have some data for it. So those data things I said before, mileage, color, model, those are all variables that we want associated with the car. And there are a bunch of functions that we want. So accelerate can change the speed over time, as would brake. Turn left, turn right would change its direction. We could get the weight of the car. So these are all functions a car can perform. So data and functions together making meaning with car. So working with classes, you want to create an instance of the class, make an object. So if you just say class, if you just do this, this tells processing, this is what a car should be. Make it instance actually takes that definition and makes a single car. This is how you do that. Car. So instead of string, int, capital C, car. That's the thing we just made. We made that. And we're giving it a name, just like any other variable name. My Beetle equals new car. So we're taking that definition, we're saying, hey, give me a new one of those. Make a new instance of car for me now. Now we can call functions on the object. My Beetle dot accelerate. Turn right. And we can use the data in the object. My car weighs plus concatenate my Beetle dot weight. Right now we have all this stuff now just encapsulated in one instance, one variable, my Beetle. And we can access all the values of that instance of that car and all the functions. Here's an example of how to make your very own class foo. I highly recommend that we actually do this. Make those capitalized here by convention. Class foo. It has a value, an integer value, by default set to 0. Now here's a special function. If you have a variable name or a function name that's the exact name of your class, that's called the constructor. It's called new when you make a new function and you say, hey, I want class, make a new foo, it directly calls that constructor. This is how you set it up. That's how you get it started. So if we pass foo into 5, v would be 5. V would be then assigned to the value member variable. And you could access it and use it. Now, we have our foo value 5. So foo is the class. Test object is an object, so it's an instance of class foo. And you can treat it as such. Now here, let's say we have our class foo. Oh, these slides. Pardon me, I'm making an editorial change on the fly here. Isn't it? So we have test object, which is a instance, which is a variable that can hold a foo. All right, so if you just had this left-hand side here, foo test object, you would have an empty reference. It points to nowhere. There is no instance of foo for it to attach to. So let's attach one to it. We're doing that by making a whole new instance of foo. New foo with 5 as the parameter. So now we have foo with the value member variable being 5. We can change its value by doing test object dot value equals 15. So the dot accesses the val member of the foo class. And members are simply variables that we associate with that class. Member variables. So object initiation, that's a constructor, like we talked about, the capital F foo function inside the class definition of foo. So you may want to follow this naming convention. This is kind of handy. So you can tell when you're dealing with a member variable or dealing with some other variable you define elsewhere, like a global or a local variable or an argument in a function. So you can prefix all of your member variables with m underscore. So in this case, we would have int m underscore val. And so whenever we want to use that value, you have in its name, you have a bit of recognition of like what it is, that it is a member variable. So objects, we want to use them because we want to hide details to the world. We could have these be almost little black boxes that you could write a cool class that does something awesome. You could just simply give that code to someone else and you want them to use it and use it easily. So they could just say, hey, new super happy fun star. If you made a super happy fun star class, you give them that code and they could simply say, import your code and say, hey, I want one of those. So they'd do super happy fun class, and then they give it a name. It's probably something lame like X or my star. And you'd set that equal to new super happy fun class, right? And then you could set your my star, which is the instance of super happy fun class. You could set its X and Y locations to be whatever you want. And you can have all this complicated code. You can have the spinning animation. There could be particle effects going all over the place, color transformations. All of that's contained within your super happy fun star class. And so now using something complicated is now easy for someone else because you've encapsulated all of that hard work, all of the tough stuff in a class and exposed a way to use it easily. So it simplifies whoever's using your class, it simplifies their world. It allows the details to be changed later, right? So you could use a bunch of classes, a bunch of your own super happy fun stars all over the place. And if you want to change how they operate, you simply change the class definition. And then that would apply to all the stars next time you compile and run the code. And objects are passed by reference. So this is where this is coming back. So objects and arrays are passed by reference. Let's take a quick look at the pass by reference example. Get out of there. Our pass by reference or value is the name of the project. All right, so here is a class. Looks familiar, right? We'll leave it for right now. I recommend you use uppercases to distinguish what classes definitions are, but lowercase works as well. We have our member variable val, default set 0. We have our constructor, the thing that gets called when we make a new instance of the class. It takes v as a value, and val gets assigned that value. Setup, window title, frame rate 30, 600 by 600 size, background is white. We're making a test int value of 5, integer of 5, and we are making a new foo right here. And we're giving it 5 as the default v value that's mapped in here and then assigned to the value member variable. And so you can do the printing here. So test int before the call, and then what the value of your test object as your instance of foo is called. Test object instance of foo. You can see what its .val member variable contains. We have a function copy for variables, test int. We'll take a look at that. Reference for objects, test object, and then so we will print those out. Let's take a look at these functions. Copy for variables, right? So here we're using integer. So these are plain variables, primitive data types, as we call them. So a, the function like we talked about last time, a test object will exist in its own box. When we call copy for variables here, what we're doing is we're making a whole new box called a, and we're copying the value from test int into that new box. Right, so now we have a copy. So a gets a plus 5. This local variable that we defined here, this new box, will have a value of 10, and then it'll disappear because we don't return it. Now, when we're looking at reference here, so our reference for objects, it's taking foo a as a parameter. It needs a foo. And so what do we do here? Well, we take a.value, and we want to assign it a.value plus 5. Well, this is passed by reference. So what we have here, see how we call this, we're simply giving it test object. We have our foo that exists in our draw function, and then we call reference for objects. So now what we actually have is this a, this foo a, but it simply has a points to that box. It references that original box. Doesn't copy a new one, references the original. So now when we say a.val plus 5, we're updating the value in that original box. A is sort of like a reference to that. So now the original one is actually changed to 10. Let's take a look. Here, this will just be, no. No, get out of here. There we go. Right? So this first one is the copy example. Okay, so I guess our values before. Our test int is 5. Our test object is also 5. Now we're doing copy for variable and test int, and we're also doing reference for objects on test object. So both of these functions are being called, and we want to see what their values are. So the first one stays at 5, right? We made a copy of it, added 5 to that copy, and then ignored the copy. So this original didn't change. But now we want to inspect test object.value, which started at 5. So we've got test int. And then by reference, we add 5 to the reference, makes it 10. And so now test object has a value of 10. So that's the difference between pass by the value, pass by copy, and pass by reference. It's important to know when we're dealing with these. Questions about that? All right. I can tell this is thrilling, right? I'm very excited about this. This is the vegetables. All right, so I think we went over this. This is, you can review this slide. This is sort of basically stating what I had said through the example. Here's a little animation to show that off. Lovely PowerPoint animations. So we have test int, pass by copy, make a new copy of A. Oh, I accidentally, one sec, I'll fix that for the slide deck later. That was a copy and paste error. And then that value gets updated to 10. We throw the box away, test int, and draw function still 5. All right. So objects are all passed by reference. Function is to reference the object. It'll change the object. This is what we said before, right? So this is, we'll revisit this when we know what objects are. But we know what objects are now. So let's take a look. Test object is 5. We call pass reference the pass reference function. That gets A. But A is now simply pointing to the original test object, the original box. And then it gets changed. We're done. So we don't expect you to write your own classes for this course, but we expect you to sort of like understand how they work, and we encourage you to try. Right? We will use classes defined by other people, like when you're using images or sound. What you're doing is you're referencing a bunch of maybe complex classes, pretty complex classes that other people have made that you simply import and use. Okay, let's take a look at the star class. Get out of here. The star class example. All right, here's our star class example. So we're making a star. Member variable x position, member variable y position. We're not doing anything in the constructor. But we have a draw me class. So this looks much like before. We have a length, we have an offset. The length is 40, the short offset is 20, so the major diagonals will be 40 long. The others will be offset by 20. Stroke weight, we're drawing our two up in our vertical and horizontal lines. Then we're decreasing stroke weight and drawing our two diagonal lines. But now we're making a move function in our star class, a member function called move. Now, what that does is it takes an integer x and an integer y and makes the position equal to those x and y values. So we can actually move it. And we're giving it another function called move down. And it takes an integer. This is how many pixels to move, to shift the star downwards by. And so we're adding to the in position, or adding to the member variable y position. So going down. All right, so we're going to make one example. We're going to make a new star called G star. I'm really tempted to go Arcus and do Ninja Gaiden runs and talk about Swag Star, but I will refrain. So now we're making an array of stars, an array of an object we created. We'll call it G star list, and it's going to get 10 stars. So 10 new instances of star, each one indexed in our G star list array. All right. 60 frames per second, 600 by 600, background to white, calling smooth for anti-aliasing to make the stars look good. Now we're going through, and for each of the stars in our list, we're going to move them. We're going to set their positions. We're going to move them to be spread out horizontally. So this is all our setup function. Now we're going to draw. We're wiping the background white again, so all the previous drawing and setup will be gone. Here's some example with a single object. You can take a look at that if you want. Here is for multiple objects. So what we're doing here is we're counting up from 0 to 10, or from 0 to 9, and we're moving down the index I, so first starting with 0, so 0 index will move down by 0, so it'll stay the same, and then we're going to draw it. Now we're going to go through the next version of the array, and I will be 1. So now we're going to move index 1 star down by 1 pixel and draw it. When I is 2, we're going to do index 2 down by 2 pixels and draw it. And then 3, move down by 3 pixels, draw it. 4 by 4 pixels, draw it, etc. all the way to 9. So we'll move that last one down by 9 pixels per frame and then draw it. Let's take a look. Right, so that first pixel, index 0, the first star, index 0 is not moving. That first one, index 1 is moving down by 1 pixel per frame. And then the next one will be double the speed, next one will be triple the speed, etc. Right, so now we're using objects and arrays together. And this is how we get them to move. So now we've combined arrays, classes, and iteration to make something that could be horribly complex into something much more manageable. All right, so we won't have too much to go over next time. I know we went through this fast. I'm going to show you one more example very quickly that will then build on next class. We'll actually actively modify this code. Sprout. So this is a slightly more complex class that I made for you. This example, we have a class called seed. And the seed's actually going to change itself over time. It's going to, in the draw function that I gave it, it will we'll start with first sprout. Actually, we want to get rid of that. There. So for every stage, where stage is defined by how long since it's been planted, divided by 1,000. So every second, we'll go to a new stage. First stage, why did this happen? We'll be drawing a seed. Second stage, we'll be drawing the first sprout. Third stage, we'll be drawing a first leaf. Fourth stage, we'll be drawing a big sprout. And then afterwards, it's going to be a flower. And you can see the code for drawing each one of these here. And then the last one, draw the flower. So a little bit of fun. So now basically our entire program, if someone gave you the seed, this is all you would have to do with it. Black background, 600 by 600 window, making a new seed at 300 by 300. And with draw, we're simply setting the background to 0 and calling seed.draw. The seed takes care of itself. All right, so we're going to take this example and make it so we can plant a few seeds wherever the mouse cursor is. And we'll do that starting this class. And the next class will also be covering review. And I know I've kept you over 2 minutes. Thank you for the extra time. Please leave if you need to leave. I'm happy to answer questions, etc. Have a wonderful day. Have a great weekend. Stay warm.